Hello and welcome to another video. Today we're going to be talking about Aquinas' theorem, which tells us that every field F also satisfies the axioms of an integral domain. Now, most of the axioms of both the integral domain and the field match. In the case of the integral domain, all of the axioms of the integral domain are also an axiom of the field. The only difference, the only one which is an axiom of the integral domain and isn't of the field, is the one which tells us that for every two elements from the underlying set of the structure we're talking about, which are not the additive identity, cannot as their product give the additive identity, which is what's written here. Now we shall, the proof is by contradiction, so assume the converse. And now, that is, assume that there exists some element A in the underlying set of the field F such that A times B is equal to the additive identity and A is not itself the additive identity. That's all nice. Well, alright. Well, since A is an element of a field, that means that there must exist the inverse, right? That's one of the axioms of the field. So we can write that B is equal to A inverse times A times B. Alright, seems reasonable. But also fields are associative, so we can obtain this. But we know that this is 0. So we have the A inverse times 0, which itself is of course 0, now, or the additive identity. Now, this is a contradiction, because we only require of the element A to be non-zero. We haven't specified anything about the element B, it's simply a random element. So if this were true, then the only admissible underlying set of a field would be the set which would contain just the additive identity and nothing more, which is obviously nonsense, because we can construct some other fields which do not have a near empty underlying set. So this is a contradiction, and this concludes this short proof.